This is 0654 question paper 4.3 from Winter 21. Slightly nicer question, this one, question 9 and question 6. I think question 6 was a bit of a meh. But anyway, let's go for it with question 9, get our confidence back a little bit. So, we are firstly told a little bit of information about a car, and you're being asked to draw a speed time graph. Alright, now hopefully you can see mine just about. You're told that we drive at 12 meters per second for 15 seconds. So first thing we do, draw a nice horizontal line at 12 meters per second. That's told in the question, so hopefully nothing too challenging here. And we are then told that the driver applies the brakes, which brings it to rest. Okay, now rest means speed equal to 0. So you're expecting at 40 seconds, so that's 15 plus 25, 40 seconds, we're going to have 0 speed. Okay, now we draw a nice straight line down there. Why straight line? Because we've got a constant deceleration. Actually, if they didn't include that bit of information, you could draw any line that connects those 2 points. If I can just something like that. You could draw anything going around like that. Okay, but because they've said constant deceleration, it means you've got to do a straight line down between the points. Okay, that should be a nice starter for 20. Get our confidence back a bit now, a bit happier. We're then asked to show that the acceleration, or even better, a showing question, right? You should get this number. Okay, we want to show that the deceleration of the car is this. Well, acceleration is the change in time, in speed over the change in time. Acceleration is change over time. Okay, and therefore we're going to have a change there from 12 to 0, so change of 12, in a time of 25 seconds. So therefore we're going to do 12 divided by 25, which is indeed 0.48. Now, as I've spoken before in sort of similar questions, the issue that a lot of students will have here is that they will forget about that time. The time is the time interval when you were doing that certain thing. So in this case, we've got a 25-second interval where we're speed changed, and so we'll only use the 25 seconds. A lot of students would use 40 here because they get a little bit confused. So it's not the value of the time, it's the change in the time. Okay. Let's crack on. All right, we're told the mass of the car. Oh, come on. Mass of the car. And we're asked to calculate the force. Well, forces make acceleration. FMA. You know the mass. You know the acceleration. You can multiply those two numbers together, get a value, 2 marks, nice and simple. Now, the point here would be, what do you do if you didn't know what's going on in the previous question, number 2? Okay. You might not have got that acceleration. You might have struggled, whatever. You may have written the wrong thing and not got that mark. What should you do in that next question? Well, you need to use the value you are given. Okay. In the previous question, you were asked to show, that the value is 0.48. If you, for whatever reason, found that the value was 0.52, then you should use 0.48 because they have told you that value. Okay. So just be a bit careful here. Even though it's a nice easy question, you need to use the right numbers, which are 0.48 and 1,200. Okay, let's go on. Now a bit of a working question. Oh, lovely. Okay. The braking distance of the car is 150 meters, and we use our answer from 9 to calculate the work distance, with the work done over that distance. Well, again, it's just a multiplication. It's a nice question to follow up that question 6, isn't it? Work follows the direction. Work follows the distance. Okay. In other words, when you've got a force and a direction, they must be in the same distance. They must be in the same direction in order for work to be done. Okay, work equals force times distance. You've got a force of 576. You've got a distance of 150. Multiplying together, and we're getting a big number, 86.4 kilojoules or 86,400 joules, whatever you prefer. All right, last bit here, and I think this is a good one to finish on. Describe the main energy transfer. Well, let's think about it. When the car brakes, it is moving, and so therefore it has the energy of movement, aka kinetic energy. All right. When it stops, due to that resistant force, due to that braking force, it is going to have increased thermal energy, and you can feel that when your hands rub against each other. Okay, friction, resistance will generally cause things to heat up. Okay, and so that thing means that our kinetic energy has become thermal energy. A nice conservation of energy question just to kind of finish off here. I think you can agree, a bit nicer now. Okay, we've gone over the nasty bit. Hope that helps, guys. Let me know if there's any questions. Please do subscribe to the channel if you want some more updates. They'll come straight into your feed. If not, carry on with your physics revision. I'm sure you've got this. All the best.